Okay. Okay, so today we're going to talk about the difference between solving equations and solving inequalities. We're going to do the left side, solving equations, and we're going to see how that is different when we're solving an inequality. Before we get started, the one thing that you need to keep in mind, the main difference, is that with an inequality, there's certain times when you need to flip the inequality symbol. Hopefully you remember that you flip your inequality. When do you flip it, Matthew?
When the x is a negative.
Not necessarily. You flip your inequality when you divide or multiply by a negative. Go.
Happy birthday.
Shh. Okay. So we're going to go through and we're going to solve these and we're going to talk about how we can represent the solutions to these equations on a number line. So, real simple, the first one, there's no distribution to do, there's no combining like terms to do. I can just start by isolating my variable by moving one of the variable terms to the other side. Always use inverse operations. Shh. Use inverse operations to move variable terms to the opposite side. When you're moving an entire term, it's always going to be through subtraction or addition. And I generally recommend you move the smaller variable term because it just helps it so that you don't have to deal with negatives. So I'm going to subtract 6x on both sides to move that 6x to the other side. And I'm left with 1x or just x. Everything you don't touch comes down. And now I need to move the constant that's next to the x on the other side. Again, if you're moving a whole term, you're going to do an inverse operation. I'm going to add 3 on both sides. And this time I get x equals 6. So my solution is that x equals 6. You can check your answer. I'm not going to do this for most of them, but we will do it for the first one. 7, and I'm plugging in my solution, times 6 minus 3 equals 3 plus 6 times 6. 7 times 6, 42, minus 3 equals 3 plus 36. And then you should get 39 equals 39. So this is the solution to that equation. We're going to represent that on a number line. I'm going to just randomly number this. Let's see, 0, 1, 2, 3, 4, 5. That won't work, so I'll put 0 here. Negative 1, negative 2, negative 3, 1, 2, 3, 4, 5, 6, 7. My solution is just 6. It's the only possible value that makes this equation true. So I'm going to plug in 6 on the number line. And that is the only way I could represent 6 as a solution on the number line. Now, to compare that with the inequality, the process is going to be exactly the same. I'm just going to subtract 6x on both sides. And I get x minus 3 is less than 3. And then I'm going to add 3 on both sides. So when you add 3 on both sides, you get x is less than 6 this time. I'm going to number my number line the exact same way, and we're going to see how this solution is different depending on the inequality symbol versus the equal symbol. So again, my solution is that x is all values less than 6. That means that 6 is not one of the valid solutions for this inequality. So if I want to check my solution algebraically, I'm going to plug in a number less than 6, not equal to 6, because that would not fit in my solution set. I think 0 is going to be the easiest number that is less than 6 to plug in. So I'm going to choose to plug that in and see if my inequality is true. Both of these terms cancel out completely. So I can just write negative 3 is less than 3, which is true. So I've confirmed my solution is all the values of x that are less than 6. Since 6 is not one of the valid solutions, I'm going to put an open circle, just like when we were doing domain and range, and my solution was not equal to 6. I don't put a closed circle, I put an open circle because it's not equal to 6. Then, since my solutions are all the values that are less than 6, I'm going to draw my arrow to the left to indicate that my valid solutions start at 6, but are not equal to 6, so it's an open circle, and then continue into negative infinity, where those are my valid solutions. Let's do a couple more examples. Same kind of process here, it's just this time I have to combine like terms. I generally box my variables when I have like terms, so I remember to include the sign that is in front of that variable with it. And then when I combine them, I don't forget that this is going to be 6 minus x, which should be 5x. And then you get 5x minus 7.2 equals 2.8. I need to isolate my variable by adding 7.2 on both sides. I'm going to add 7.2, and that's going to get 5x all by itself. So I get 5x equals 10. I cancel the coefficient, and I'm out of room. But the 5 is going to cancel with 5, and I get x, and 10 divided by 5 is 2. So my solution is x equals 2. You can check that algebraically the same way we did above by plugging in 2 for x to see if it creates a true statement. But again, I'm not going to go through that process only once. I'm going to label my number line. Let's see. Negative 5, 4, 3, 2, 1, 0, 1, 2, 3, 4, 5. Perfect. Negative 5, negative 4, 3, 2, 1, 0, 1, 2, 3, 4, 5. And again, when you have a single solution on a number line, the only way to represent that is with a closed dot on the number line. Because x is equal to 2, it is only on 2 that my solution exists. Same process. I'm going to kind of skip a lot of the work I showed because really it should be the exact same. It's just the symbol is going to be different. I'm going to add 7.2 on both sides, and you should get 5x is less than 10. And then I'm going to divide both sides by 5, and you should get x is greater than 2. Sorry, I misspoke. 5x is greater than 10, so x is greater than 2. My solution is all the values of x, where x is greater than 2. I'm going to copy the exact same number line, and we're going to represent our solution. So these are the kinds of problems you're going to see on your test. It's not just solve the inequality and find the solution set written as an inequality. You're going to need to solve the inequality, find the solution set, and then find the corresponding number line that matches your inequality. So 2 is where the boundary is for my solutions. But since x is not equal to 2, I'm going to do an open circle to indicate that x can't equal 2, but x is just greater than 2. So I'm going to draw a line to the right, which indicates that x's solutions, or the solutions to this equation, are all the values of x where x is greater than 2. We'll do 2 more examples, and then there's a quick edit we need to make on the back. First, this one, the main thing that you need to keep in mind is that you have to distribute. So I'm going to distribute 2 to both, and you get 2x plus 8 equals 2x plus 18. When I go ahead and I isolate my variable, I realize that my 2 variables cancel out. So I get 8 equals 18. Since that is not a true statement after all my variables will cancel it out, I realize that there is no solution to this equation. If you can't get your equation set up in such a way where it tells you that x is equal to a number, then there is no solution to that equation, and you get a false statement, that means there's no solution. Conversely, if you were to get a true statement, there would be infinitely many solutions. Let's look at how this might be different with an inequality. 2x plus 8 is less than or equal to 2x plus 18. Again, we're going to cancel my two x's, and I get 8 is less than or equal to 18. This time, is that a true statement? It is a true statement. 8 is less than or equal to 18. So even though when you do an equation and you get a false statement, there's no solution, with an inequality, sometimes what would be a false statement for an equation is actually a true statement for an inequality. And any time after your variables cancel out, if you get a true statement, we say there are infinitely many solutions. Or you could say the solution is all real numbers, meaning that any x value you plug in to this inequality will result in a true statement. So I'm going to write all real numbers for the solution, or you can do the all real numbers symbol. If you check this algebraically, you'll see that no matter what x value I plug into this equation, it will always be true. I'm going to plug in 0. Right? Let's not plug in 0. Let's plug in 10. 2 times 10 plus 8 is less than or equal to 2 times 10 plus 18. I get 20 plus 8 is less than or equal to 20 plus 18. And you can already see if you have two 20s, adding 8 and adding 18 will definitely make the side that has 18 being added to it bigger. So that is a true statement. 28 is less than or equal to 38. So that is a true statement no matter what x value you plug in. Going back to the equation, no matter what x value I plug in, it's going to be a false statement. If I plug in 10 again, this time I get 28 equals 38, which is a false statement. So because there's no x value I can plug in for the equation to make it true, if I try to represent this on a number line, there is no points to put on it. So you would have essentially a blank number line representing your solution because there is no solution to this equation. Conversely, with the inequality, if I were to try to represent all real numbers on the number line, that would be a completely filled in number line because any number on the number line can be plugged into this inequality and make it true. So I'm just going to color the number line to indicate that my solutions are all of the numbers from negative infinity to positive infinity that are valid solutions for that inequality. And this is the main idea. Solving inequalities is not so different than solving equations, but when you do that, you need to learn how to represent it on a number line. And some situations where an equation has no solution might actually result in an inequality having infinitely many solutions. On the back, there's one thing I want to change, and the thing I want to change is this needs to be a symbol like this. So make it a greater than or equal to symbol, so that way it actually represents the dichotomy of equations versus inequalities. And I'm going to quickly do this inequality. 2n plus 4 is less than 2n. You'll notice when the variables cancel out this time, you get a false statement. So again, anytime you get a false statement as your final instance of solving an inequality or equation, you have no solution to that inequality. So there is no solution to this inequality. I'm going to post a picture of the back side of these notes filled out for the rest of class. Go ahead and finish up these notes. Compare with my notes. Put them in your notebook. They were printed upside down, so it's going to look a little weird in your notebook, but one way or the other, get them in your notebook. And then there is homework online. It is going to be graded, so make sure you finish the homework by tomorrow.